Okay, let's evaluate the function at x equals 2. So I'm going to go over to 2, and there's an output value also of 2. Now let's evaluate the function as it approaches 2. So as it approaches 2 from the left, it's approaching an output value of 1. I'm going to do this for my old eyes. There it is, I believe. Okay, let me go back here again. As it approaches 2 from the left, it's approaching an output value of positive 2, and from the right, it's approaching an output value of positive 2. Okay, let's go to the function g of x. Now, g of x at -1, there's an open circle. There's a hole in the graph. That means it's undefined. It's undefined. Now let's look at the limit as it approaches -1. As it approaches -1 from the left, it's approaching an output value of positive 1. And as it approaches -1 from the right, it's also approaching an output value of positive 1. Since the left and the right are approaching the same output value, there does exist a limit here as x approaches -1 of 1. Let's evaluate the function h at 1. Now at 1, I see a vertical asymptote. This is undefined. Let's look at the second row in part 1 of the Unit 19 review. All right, let's go to the function h of x, and let's look to the left and to the right of 1. So as we approach 1 from the left, it's going to positive infinity, and from the right, it's also approaching positive infinity. So in this case, although it's approaching both the same direction, he may allow positive infinity since it is the same, but he also will allow does not exist because it's not actually converging on the same numerical value. Let's look at the next one. Now let's go back to h of x and let's approach 1 from the left. So if we approach 1 from the left, it's approaching positive infinity. Now let's go to function j. So I go to j, I find x equals -2. This is undefined. Now let's go and find the limit. So the limit for j as we approach -2. If we approach -2 from the left, it's headed to positive infinity. As we approach -2 from the right, it's approaching negative infinity. These are different, so it does not exist. Let's go to function k. If we go over to 2, remember every function can have at most one output. The output is positive 1. Let's look at the third line. Okay, going to move this down here. So I'm going to skip over to this one first. As we approach k as we approach 2 from the right-hand side. So here's 2. As we approach from the right-hand side, we are approaching an output value of 1. As we approach 2 from the left-hand side, we are approaching, I think this is supposed to have a line right here, we are approaching an output value of -1. Because the left-hand side and the right-hand side do not converge at the same output, then the limit as x approaches 2 from the left and right is not approaching the same output value, so it does not exist. Now let's go to where m equals 1. So m equals 1, and the output is 1, 2, 3. When we look up above, as we approach 1 from the left and from the right, both the left and right are approaching with an output value of 2. Okay, in the last 4, we need to remember the rules of exponents. So when I look in the numerator, I see a degree of 2. When I look in the denominator, I see a degree of 1. When the degree in the numerator is greater than the degree in the denominator, no horizontal asymptote exists. And for that reason, we say the limit does not exist. Because it would continue to go towards infinity, up towards infinity, not approaching one output value in particular. Okay, let's look at the next one. Here we have the exact same degree, so we're going to divide top divided by bottom, taking the leading coefficients at the top and bottom to end up with 3/2. Now in the next one, I'm going to first combine these to get 2x on top, and I have 2x squared plus 4 on the bottom. Here we have a degree of 1 on top and a degree of 2 on the bottom. Because the degree on top is smaller than the degree in the bottom, I know a horizontal asymptote of y equals 0 exists, so 0 would be my answer. Okay, and this next one, now this says to take x minus 2, and I want to write it down 3 times. I know that when I go through and I FOIL it out and I distribute, I end up with an x cubed on top. On the bottom, I have a negative 2x cubed, so I have the exact same degree on top as I have on the bottom. I'm going to divide the leading coefficients to end up with negative 1/2. Okay, lastly, if I go ahead and I write this down twice, and I go ahead and I factor it, I'm really only concerned about the x. So negative x times negative x would be a positive x squared on top, and on the bottom, if I distribute this again, I get a positive 4x squared. I have the exact same degree, so I'm going to divide the leading coefficients to end up with a positive 1/4.